The first definition you come across is that of a secant line. We already have this definition. We learned it in 12.2. Well, just a reminder, a secant line is a line that intersects the circle at 2 points. So this line clearly intersects here and here and keeps going, which makes it a secant. In this section, we also are introduced to theorems 12.3, or 12.13 and 12.14. For 12.13, it says the measure of an angle formed by two lines that intersect inside the circle is half the sum of the measures of the intercepted arcs. So if you're looking for angle 1 here, you're going to add together the arc x plus the arc y and multiply by 1/2. So angle 1 equals 1/2 x plus y. This is important. Go ahead and start in your notes. Theorem 12.4 states that the measure of an angle formed by two lines intersecting outside a circle is half the difference of the measure of the intercepted arcs. So in this case, if you're looking for angle 1 on this angle formed outside the circle, you're going to take the big arc and subtract the smaller arc from it. Same thing here. You're taking the big arc, subtracting the smaller arc from it, and multiplying by 1/2. So it's 1/2 big arc minus little arc gives you the measure of your angle. Go ahead and start that in your notes as well. Good job, Witzke. Good job. All right, so in example 1, it says, what is the value of the variable? Our intersection point is inside the circle. So that means we're going to take this arc plus this arc, add them together, and multiply by 1/2 to get the measure of our angle. So in this case, x should equal 1/2 the sum of the two arcs. So 46 plus 90. So that's 1/2, 136. In this case, x is going to equal 68 degrees. Example 2. We have the angle taking place outside of the circle. So that means we're going to take this arc and subtract this arc from it, and then cut it in half. So right away I know that 20 equals 1/2 95 minus z. I have two options. I can distribute the 1/2, or I can multiply by 2. I'm going to multiply by 2 to get rid of the 1/2. So when I multiply both sides by 2, I get 40 equals, and I don't need the parentheses anymore, 95 minus z. To move the z, to move the 95, I subtract it. So I've got negative 55 equals negative z. I'll divide by -1, and I get z to equal a positive 55 degrees. So this arc is 55 degrees. All right, examples 3 and 4, same idea. Just in case you don't notice this particular part is 360, you could have done this problem the long way. For example 3, 70 equals 1/2 w minus 110. Well, here you're going to go ahead and distribute, or not distribute, you'll go ahead and multiply by 2 to cancel the 1/2. You get 140 equals w minus 110. So in this case, you're going to add over the 110 to cancel out the 110, and you get w to equal 250. So in this case, if you don't recognize the circle is 360 and you set it up, you'll still get the same answer we got the first time. Example 4. Once again, we have our interior angle, which the intersection takes place in the circle. So I'm going to add the two arcs together, cut them in half, and set equal to the angle. So 35 equals 1/2, in this case x plus 30, and I want to solve for x. So instead of distributing the 1/2, I'll multiply both sides by 2. So So I've got 70 equals x plus 30. To move the 30, I subtract it from both sides. And I get x to equal 40. All right, fifth example. This time it has a satellite in orbit. A satellite is in orbit above Earth, and it has a viewing angle of 17.5 degrees formed by two tangent lines to the Earth. What is the measure of the arc that can be viewed? So these are your two tangent lines. This is your 17.5 degree angle, and they're looking for x here. This is a lot like the problems we just saw where our angle is formed outside the circle. We know that that angle, being 17.5, is equal to 1/2 the larger arc minus the smaller arc. Well, the problem is we don't know the larger arc, but we can create an expression to represent it. So like 360 minus x, because this arc is 360 degrees minus this arc. So when we set this up, we're going to have, and I'll write this smaller so it's out of the way, 360 minus x inside our parentheses. So here, let's simplify the parentheses first. So 360 minus 2x times 1/2 equals 17.5. I'm going to go ahead and distribute the 1/2 this time just to mix it up. 360 divided by 1/2 is 180 minus x equals 17.5. To solve this, I'll subtract 180 from both sides. Remember, this is 17.5, so don't try 5. So you've got 162.5 equals negative x. Actually, negative 162.5. All right, so now to get rid of the negative, we divide by -1, and you're going to get x equal 162.5 degrees. So the viewing arc that they can see from the satellite is 162.5 degrees. Our sixth example, same type of problem. This time I don't have a diagram. I have to draw my diagram. So, a 19-degree viewing angle of the moon from a spaceship is formed by two tangent lines. What is the measure of the arc that can be viewed? So, we can draw this. So we've got a 19-degree viewing angle of the moon from the space formed by, what is the measure? All right, so we've got, let's pretend this is the moon. Oh, sorry. This is the spaceship. This is the moon. There we go. Moon. Looks like a moon. All right, so you've got a 19-degree viewing window. They want to know the arc, so we're looking for this. So it's the same setup as the problem we just solved. So we're going to take 19 equals 1/2 360 minus x minus x. Right, so we have our major arc subtracting the smaller arc from it. Let's go ahead and clean this up. 360 minus 2x. Go ahead and distribute the 1/2. You've got 180 minus x equals 19. In this case, now we need to subtract 180 from both sides. To move the 180, you'll get 161, negative 161, equals negative x. Divide by -1, and you're going to get x equal 161 degrees. So that arc viewable of the moon from the spaceship is 161 degrees. All right, so moving along. And remember, at any point, you can pause this video if you need to copy something down or rewatch it. All right, so next theorem, Theorem 1215. For a given point and a circle, the product of the lengths of two segments from the point to the circle is constant along any line through the point in the circle. A lot of words. All they're getting at is to find lengths within the circle, there are one of three various formulas you could use, depending depending on the circumstance. All right, so if you have two chords intersecting in the circle, to find the length of any one part of that chord, you can do one segment of one chord times the other portion of that segment equals one segment of the other chord times the other segment. If you have essentially two secants meeting outside of the circle, and you're trying to find the length of any one part, you should know that this piece, the inner portion, plus the outer portion, added together, then multiplied by the outer portion, would be equal to the sum of the two pieces times the outer portion. So they're allowing us to solve for missing links. And I get this is going to be confusing, but try your best. We'll start identifying these in class tomorrow. The third option, if you have a secant and just a tangent, the tangent squared should be equal to the sum of the two parts of the secant times the outside piece of the secant. All right, so these cases are important. Case 1, the products of the chord segments are equal. Case 2, the products of the secants and their outer segments are equal. Case 3, the product of the secant and its outer segment equal the square of the tangent. So let's try to put some of these to work. All right, first example, we have two secants. All right, we have two secants. And so if we remember from the previous slide, we were told that the sum of the two pieces times the outer portion should be equal to the sum of the two pieces times the outer portion. So that's what we're going to set up. We're going to take 6 plus 8 times 6 equals 7 plus y times 7. All right, here we'll simplify. This becomes 14. 14 times 6 is 84. Here, we're going to have to distribute this 7 because we can't combine anything like that. So 84 is going to equal 49 plus 7y. Now we're just going to solve this for y. So we're going to subtract 49 from both sides. So we've got 35 equals 7y. Divide by 7. And you've got y to equal 5. So for example 1 of this section, y is just 5. Class is not dismissed. You have headphones on. Keep going. All right, so the second problem of this set, we have a tangent outside equals the secant quantity times the outer piece. So to set this up, let's take our tangent squared. That's ugly z. Tangent squared equals the outer portion of the secant times the sum of the secant. So 16 plus 8. 16 plus 8 is 24. 24 times 8, I don't know off the top of my head, but I figured it out. 192. So z squared equals 192. To get rid of a squaring, we square root both sides. So in this case, z is going to equal, well, the square root of 192 is right around 13.9. So that's the length of z. All right, the next part, we have two tangents. Or sorry, two chords, not tangents. Two chords that are meeting inside the circle. So we know that the sum of these two pieces equals the sum of these two pieces equals the sum of these two pieces. Correction. We know that the product, there we go, the product of these two pieces is going to equal the product of these two. So we're multiplying. So for this chord here, we're going to have 6.5 times m, so just 6.5 m, equals 3 times 7. Well, 3 times 7 is 21. So I've got 6.5 m equals 21. To solve this, I'm going to go ahead and divide both sides by 6.5. And I've got m to equal 3.2. So the length of m is just 3.2. Those are some of the easier ones. So just remember, you just multiply piece and piece equals piece to piece. All right, the fourth example, we have a secant and a tangent again. All right, so remember, it's the tangent squared equals the outer piece of the secant times the sum of the two pieces of the secant. Here, 10 squared is 100. Here, we're going to distribute. So we've got 49 plus 7y. Well, we'll subtract 49 from both sides. That gives us 61. 61 equals 7y. We're going to divide by 7. And in this case, you're going to get y to equal 7.3. And yes, we're getting a lot of decimals. You're okay to get decimals. Don't panic. All right, so we've got 2 more examples left. Before we start either one of the examples, try pausing it and try doing 1 or 2 of them on your own. And then start the video and see if you got it right. All right, so last 2 examples, and that one's a doozy, so we'll start with this one. We have 2 secants. Well, let's remember the relationship is the outer portion of the secant times the sum of the secant, so in this case 16 times x plus 16 equals the outer portion times the sum, so 20 plus 14. So here we're going to have to distribute this. So this is 16x plus 256 equals, well, we don't need to distribute this yet. We need to, 20 and 14 become 34. 34 times 14 is 476. All right. So now we just need to subtract 256 from both sides. So we've got 16x equals 220. We're going to divide by 16 on both sides. And in this case, we get x to equal, what does x equal? 13.75. All right, last example. We have multiple variables to look for here. We've got an angle here and an outer angle. We've got segment pieces. So let's just go ahead and find this angle here, because this is using everything we've learned so far. All right, so I need the extra board space, so we're going to go ahead and erase this real quick. So this last example, here they're looking for an angle inside the circle that deals with the 2 intercepted arcs. This is from the beginning of the notes. To find y, we have to remember that y is that angle that's going to equal 1/2 the sum of the 2 arcs. So 85 and 45, well, that's 130. So half of 130 is going to give us the measure of y. So in this case, y equals 65 degrees. So we know y, so we can just kind of tag it over. All right, so now that we know what y is, we have to then go about finding x and z. Well, these are segment lengths, so they're a little different, but they're the things we just did. So to find x, you're going to take x times 10 equals, so that's 1 chord pieces product, equals the product of the other 2 pieces of the other chord, so 9 times 6. So 10x equals 54. Divide both sides by 10, and you're going to get x equal 5.4. So x equals 5.4 in this case. All right, so we have 1 more left. If I erase that too fast, pause the video about 30 seconds ago. You'll be okay. All right, so z is a tangent, and there is a secant within this circle that is intersecting the tangent z. So we should remember that formula before, where z squared is going to equal the outer portion of the secant, so 6, times the sum of all pieces of the secant. So in this case, this piece plus this piece. Well, this is 9 plus 6, which is 15, plus 6, which is 21. So in this case, z squared equals 6 times 21. Well, what is 6 times 21? 126. So in this case, z squared equals 126. To undo the squaring, we square root both sides. In this case, z is going to equal 11.2. All right, so what you need to remember is do not forget that you're going to have to be responsible for keeping track of these formulas. The easiest way to figure out when to use a formula is to look at the picture. Your diagram will look like what you're trying to use. If it looks like this, this is what you're using. If it looks like this, this is what you're going to use. And if it looks like this, this is what you're using. The same thing is true if you're talking about these two formulas. If you see that you have essentially almost the X-Men symbol with the X in the middle, that is going to be the addition of the arcs times 1/2. If you have an angle outside the circle, you're going to be taking the difference or subtracting the two arcs, then multiplying by 1/2.